Okay, welcome Algebra 2 students. This is the final target of Unit 3 on radical functions. This final target, target 21, will focus on solving radical equations. This is a two-part video, so the first part will focus on equations that involve just one radical. So to begin with, we take a look at the three-step process for solving radical equations. So step one is going to be to isolate the radical on one side of the equation. Okay, if necessary, right? We may start with an equation that already has the radical isolated on one side. So that means what you want is you want to have the radical equals some other stuff. Okay? So we want to get that radical all by itself with nothing in front of it. Okay, this should just be a 1 in front of it. Okay, nothing added onto it at the end. Now, step 2 then is to raise each side, okay, and side being the key word here, of the equation to the same power to eliminate the radical. So if this is a square root, we're going to take each side and square it. If it was a cubed root, then we'd take each side and cube it. Now, again, it's important here that you take the entire side on both sides and raise them to the same power. This becomes really important, especially when we have multiple terms on that side and we square it. We have to be very careful with that so that we're not just squaring each term, but actually squaring the entire side, so actually taking it and multiplying it by itself. When we do that, we're going to end up with a linear, okay, a quadratic, or some other polynomial equation that does not have a radical in it. Okay, then finally in step 3, you're going to solve the polynomial equation that you obtained from step 2 using any technique that we learned in previous chapters. So if we end up with a linear equation, we're going to undo the operations to solve it. If we end up with a quadratic, we're going to try factoring to solve it. If that doesn't work, we can use the quadratic formula. Polynomial equations, we're going to have to look for possible solutions and check them using synthetic division. Most likely, though, we're going to end up with either linear or quadratic equations once we get rid of the radical. All right, so let's begin with some examples. So this first one, we have the cubed root of x minus 9 equals negative 1. So my first step is to isolate the radical. So here's my radical. I want to get that by itself. So that means I want to get rid of this minus 9, so I'll add 9 to each side of the equation. When I do that, I end up with the third root of x equals 8. And then I can go ahead and cube both sides. Right? So I'm cubing because it's a third root, and the opposite of a third root would be a third power. So I take that third power of each side. That undoes the radical, and I'm left with x equals, and 8 to the third power would be 512. All right, now it's important that we check our solutions. Okay, because of this, this cubing on each side or squaring on each side when we have a square root, it is possible that we can introduce a solution that doesn't actually exist, especially when with even powers like squaring. But it can happen with cubes as well. So it's important that we do a check to see if this actually works back in the original equation. So putting it in, okay, we have the cubed root of 512 minus 9 equal to negative 1. Cubed root of 512 is 8. Minus 9 equals negative 1. Okay, so negative 1 equals negative 1. So it does, in fact, check out. So x equals 512 is the solution to this equation. All right, our second example, we have a square root this time. So in this case, we don't have to isolate the radical, it already is. We don't have anything along with that square root. So we're going to go right ahead and square both sides. So squaring the left side just undoes the square root, and we're left with x plus 25. On the right side, we're squaring 4, so we get 16. Now, this is just a linear equation. Okay, so we solve it by undoing each side. So we subtract 25, and we get x equals -9. All right, now going back and checking that in the original equation, we have the square root of -9 plus 25 equal to 4. So -9 plus 25 is 16. So we get square root of 16 equals 4, and that does equal 4. So it checks out, and x equals -9 is in fact the solution. All right, why don't you go ahead and try this example, pause the video, and once you think you have it, resume and see what the solution is. All right, so for this one, we first have to get rid of this 2 because we want to, again, isolate the radical, so we're going to divide both sides by 2. That leaves me with the cube root of x minus 3 equal to 2. So now I've isolated my radical on the left side, so I can raise each side to the same power to undo that radical. So each side goes to the third power. And that leaves me with just x minus 3 on the left side. On the right side, 2 to the third power is 8. And then I need to solve the equation by adding 3 on both sides to get x equals 11. All right, and then going back to check it in the original equation, okay, substituting 11 in, we have 2 times the cube root of 11 minus 3 equal to 4. So this is 2 times the cube root of 8 equals 4, or 2 times 2. So we do get 4 equals 4, and it checks out. So we have a legitimate solution here of x equals 11. Okay, this final example is probably about as hard as a radical equation is going to get for us. And that's because we have more than one term on the other side from where the radical is. So if we follow our steps, we want to first isolate the radical, which is already done. And so we can go ahead and then square both sides. So we square the square root of 7x plus 15, and we square the x plus 1. Okay, so this is where it becomes very important that we actually square the entire side. Now, sometimes it may help to actually write out what that is. X plus 1 times x plus 1. That's what it means to square something. Multiply it by itself. And then when I square the square root of 7x plus 15, I just get 7x plus 15. Now, when I actually multiply this out, I get x squared plus 2x plus 1 equal to 7x plus 15. So now if I look at what I have left after I've squared both sides, I can now see that I don't have just a linear function. This is in fact a quadratic function or quadratic equation. So in order to solve a quadratic equation, we must get it set equal to 0. So I'm going to subtract 7x from both sides, and I'm also going to subtract 15 from both sides. Okay, that'll get me my 0 on the right side. And over on the left, I'll have x squared minus 5x minus 14. So to solve the quadratic, I could use my quadratic formula, or in this case, I can factor this pretty easily. It would be x minus 7 times x plus 2. So setting each one of those factors equal to 0, we get x equals 7, and x equals -2. All right, now we have to go back and check, make sure that those solutions actually work in the original equation. So let's first check x equals 7. So putting that into the original equation, I'd have 7 plus 1 equals the square root of 7 times 7, which is 49, plus 15. So we get 8 equals the square root of 64, which does equal. Okay, so 7 checks out, it works. But let's also check negative 2. Okay, so substituting that back into the original equation, we get negative 2 plus 1 equals the square root of 7 times negative 2, which is negative 14, plus 15. So that gives me negative 1 equals the square root of 1. So negative 1 equals positive 1. That does not check out, okay, because those do not equal each other, which means that x equals negative 2 is not a solution. Okay, this is what we call an extraneous solution. Because we solved everything correctly, we did all of the steps correctly, but we still got a solution that doesn't actually work in the original equation. So the only actual solution we have here is x equals 7. All right, so that does it for the first part of Target 21. Okay, please make sure to check back and check out the second part of Target 21 real soon.